Hey guys, Mr. Pusky here. Hope you're having a good day so far. Excuse me. Sorry. Started a video and start coughing. We are actually moving into chapter 11. We're trying to jump around and make sure we cover the most important stuff for you guys for geometry. In chapter 11, we decided chapter 10. We may come back to it later, but for now we're going to get into chapter 11, which is areas of different shapes, okay? And areas, perimeter is the outside of shapes, and then areas like the inside of shapes, okay? So we felt like this would be more important for you to know going forward for like Algebra 2 and onward, okay? So let's read the name of the lesson. Name of the lesson, ready? 1, 2, 3. Areas of triangles and parallelograms. Essential question, ready? 1, 2, 3. How do we find areas of triangles and parallelograms? Okay, so hopefully you guys remember parallelograms have lots of different characteristics. The biggest thing is that the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, that kind of stuff, okay? Basically, it's going to be a shape that looks something like this, where these are congruent, these are parallel, these are parallel. That was kind of sloppy, but you get the idea. Okay, so the bases of a parallelogram are either pair of parallel sides of what? Parallel sides of a parallelogram. And the height of a parallelogram is going to be the perpendicular distance. The what? Perpendicular distance between the bases of a parallelogram. So we're going to draw a parallelogram over here. And try to not make it so sloppy. And that's not parallel. Let's try to fix that. I cannot do this, guys. That might be a little bit better. That's more like a parallelogram. So, the bases of a parallelogram are going to be either pair of parallel sides. I'm just going to draw an arrow pointing right here. Okay? That's a base, or this is a base. Usually the base is at the bottom too, the bottom of a parallelogram, but but any pair of parallel sides, either pair of parallel sides or parallelogram are called the base. The height is going to be this. It's going to be the distance between from between each parallel pair of sides, and it's going to be the height. So we draw a line like this. This is the height. That is the height. Okay? So the height is going to be the distance between bases of a parallelogram. Okay? All right. So we have some postulates here. We have some stuff to fill out. So, area of a square postulate. The area of a square is the what? The square of the length of its side. So, if we have a square like this, and we have a side length of S, and these are all S, do you guys know what the area of a square, how we could write that? Well, like, hopefully you remember, like, for a rectangle it was like, length times width. You guys remember that from a rectangle? What is it going to be for a square? Well, if we did length times width, which is this times this. What about for a square? What do you guys think? Area is going to be equal to, it's going to be side times side, which is going to be, so S times S, which equals side length squared. Okay? So that's just a, when you find the area of a square or a rectangle, and a square is a rectangle, you do length times width. But in this case, all the lengths and widths are all the same width, or all the same distance, which is S. Area congruence postulate. If two polygons are congruent, are what? Then they have the same area. Area addition postulate. The area of a region is the sum, is the what? the sum of the areas of its non-overlapping parts. I should have mentioned up here, hopefully this makes sense to you guys, is basically if you have two congruent shapes, they're going to contain the same amount of space inside of them. They're not going to be different. That would be kind of crazy. Area addition postulate is something like this. If we had a shape like this, that was kind of sloppy. Let's fix that. Okay, I'm really having troubles today. We have a shape like that, for example. It's kind of like a Tetris thing. So basically what you're going to do, instead of like trying to find the area of this entire shaded area, what you can do is you can split it up into two smaller parts. So I can make a square and a rectangle, or else I could also make two rectangles like this. Okay? So either way, you can... I'm going to use two different colors here. Let's go like, we can go like this, or we can go like this. Okay, so basically if we did that, or like that. Okay, so area addition postulate just says if you have two shapes that are overlapping or are kind of a weird shape, you can break them up into smaller parts that you do know how to find the area for. We can find the area of a square and a rectangle really easily. We can't really find the area of a shape that's like kind of like this, okay? So the trick is to break it up into smaller parts. We talked about earlier, the area of a rectangle is going to be what? Product of its length and width. So, area of a rectangle equals length times width. Okay. Area of a parallelogram is going to be the product of its base, and its corresponding height. Of its what? Base and corresponding height. So area of a parallelogram is going to be base times height. And actually, a rectangle is a type of parallelogram, right? So if we have a rectangle like this, the length and the width of this rectangle, the width and the length of this rectangle is also the height in its base. So it's the same thing, okay? Because a rectangle is a type of parallelogram, but the base and height becomes the length and width. Okay, but this is probably the most important one because this will work for any parallelogram instead of just rectangles. But most people do know this length times width one for rectangles. Okay, an area of a triangle. Does anyone know the area of a triangle? The area of a triangle is 1/2 the product of a base and its corresponding height. So area of a rectangle equals 1/2 base times height, or area equals base times height over 2. That was really bad. Guys, I'm on the struggle bus today, and this is really frustrating. Okay. So, another way, and you guys know why an area of a triangle is 1/2 base times height? Well, let's look at a rectangle here. And I'm going to split it in half. So we said that the area of a parallelogram or rectangle was base times height, right? But how many triangles do we have inside of this rectangle? We have 1 and 2. So isn't an area of this triangle going to be 1/2 of the base times height? Yeah, you can take any triangle or any parallelogram and split it into two triangles, and that's why we get the 1/2 base times height. Because two triangles make up any parallelogram like that. Okay? That's a good way to remember it. So if you have base times height a lot of people remember the base times height over 2 or 1/2 base times height, but sometimes people forget the area of a parallelogram. Just remember that it's gonna be double 1/2 base times height, which is just base times height. All right, so let's go ahead and do example 1. Find the area parallelogram ABCD. You only know it's a parallelogram, so I'm just gonna write out the formula every time, so I know what I'm working with here. So it's 1/2, or no, it's just base times height. Sorry. So, what is the base and what is the height of this parallelogram? We have 8, 4.5, 9, and 4. So if you recall, the height is a perpendicular distance from one base to another base. Okay, so this right angle right here, it doesn't really go from a base to another base. It goes from like the corner to corner, which is not actually a height. The height of this one is actually going to be 4. Okay, and the base is going to be what? What do you guys think? Base is going to be 9. So it's going to be area equals, once you figure out, this one's kind of confusing because you got a lot of things to choose from here, but if we had 8 and we had like a right angle to this other side, or we had the 4.5, I don't even know what they're doing with the 4.5 there. That's kind of confusing to try to do. But for this one, it's going to be base times height, and the base is 9, and the height is 4. And what is 9 times 4 going to be? Equals 36. And that's it. That's all you got to do. Okay. All right, why don't you guys go ahead. I'll leave this one right here for you to go ahead and give checkpoint 1 and 2 a try on your own. Go ahead. Okay, and sorry, I probably should have mentioned that we're working with our triangle here, which is a little bit more tricky. But so again, area of a triangle equals 1/2 base times height. But I'm actually going to use I'm just going to use base times height over 2 because I think that's a little bit easier to work with. So what's the base and what's the height for this triangle here? What do you think the base is? So we got like 5 numbers here, but actually the base is not any of these 5 numbers. It is actually a sum of 2 numbers. So the base is actually going to be these 2, right? Because the height is at a right angle from the base to the other corner like this, okay? So the base is going to be 45 plus 21, which is going to be 66. I'll actually write it out. 45 plus 21, which equals 66. And the height is actually going to be 28. The height of triangles is a little bit goofier. It's actually, this one over here keeps throwing me off, why it's at like a right angle like this. Actually, let me check something really quick. You know what? I always did this first problem the same way every time, but this actually is a base and a height right here. I was looking at it a little bit more closely. This is the base right here, and this is a height from the base to the other base. So you could also have done 8 times 4.5, which also equals 36. So actually there's 2 ways you could have approached that problem. I was looking at it, I'm like, this is throwing me off here, but it's actually correct. You can do it both ways. Okay? So this one down here, yep, remember the base has to be at a right angle going from the corner to corner, or from the base to the opposite corner, basically. So we're going to plug in for this base times height over 2 now. So we got 66 times 28 all over 2, which is going to equal, running out of room here, 1848 over 2. So A is going to equal 924. Okay, so the height of any triangle or parallelogram is going to be any length that's at a right angle, like this is, at a right angle, going to the other side, where it touches the other side or other corner of a corner of a triangle, or the opposite side of a parallelogram. Okay? All right, and then checkpoint 2, well, what's our base, what's our height for checkpoint 2? Well, we see that we have this is a right angle, so that means that this has to be the base right here, because the base is at a right angle to the height. So we're doing area equals base times height. Area is going to equal, the base was 17, the height was 7, so we got 17 times 7, and the height is, or the area, sorry, is going to equal 119. Okay. I think hopefully on your quiz you won't have ones with all these different. There's a ton of numbers happening in this one over here, and I think it's just a little confusing. But the base is always at a right angle to the height. Okay, so just keep that in mind. All right, let's do this one right here. This one's a little bit tricky. So it says solve for unknown measures. The base of a triangle is 4 times its height. The area of the triangle is 50 square inches. Find the base and height. So what we're going to do is we're going to draw a picture here. It says the base is 4 times its height. So what I'm going to do is I'm going to draw a height, and I'm going to draw a base that's about 4 times as long as that. Okay? So I don't know if you remember a while ago we talked about these kind of problems. The base is 4 times its height. Well, if the base is, if the height is x, what is 4 times the height going to be? It's going to be 4x. Okay? So this is kind of like those problems with like the angles where we did like, a 30, 60, 90 triangle where this was 3x and 3x and 4x, and we had to add them up to 180. Remember doing that a while ago? Okay? Erase all this stuff. So it's a similar kind of thing. We're going to find the area of this triangle, which we know is 50. We're going to do area equals base times height over 2. And we're going to plug in what we know. So we know the base equals 4x, and the height equals x. We're going to plug in, we know that 50, the area equals 50. So we're going to do 50, let's move it up a little bit. 50 equals the base, which is 4x, times the height, which is x, all over 2. Okay, so yeah, just stick with me on this problem here. It's kind of tricky, guys. Just make sure you, just don't panic with this one, okay? So now we need to solve for x. We need to solve for x. So how do we get rid of that 2 in the denominator here? How do we undo dividing by 2? We're going to multiply by 2. That's called fraction busting. 2 times 50 is 100. And then what is 4x times x going to be? That is 4x squared. All right. And we are looking for x. Now, how do we solve for x here? What are we going to do to get x alone? We're going to get rid of the square or the 4 first. We're going to get rid of the 4. And how do we get rid of the 4? We're going to, instead of multiplying by 4, we're going to divide by 4. So we get 25 equals x squared. And now, you geometry students, how do we undo a square? We're going to do a what? Square root. So x is going to equal 5. It's actually going to be plus or minus 5, but we're not going to use a negative distance for this because it's a distance. And x was the base, or the height actually. The height equals 5. How do we find the base? Well, the base was 4 times the height, which is 5, which equals 20. So we get 20, and we get 5. Okay? If that one was kind of confusing, just don't panic. We're not going to throw you to the wolves here and make this, really hard for you, okay? It's just good to know how to do these kind of problems. All right, moving on. All right, this next one's actually kind of a good one. So this one's a little bit easier, checkpoint 3, but it's a similar kind of process here, all right? So we have a parallelogram has an area of 133 square feet and a height of 19 feet. What is the length of the base? So we know, what's the formula for area of a parallelogram? Area equals what? Base times height. So what you always want to do is you always want to write down what the different variables and see if you know any of them, okay? It says the area is 133, so we can plug in 133 right here. We know the area. What else do we know? Do we know the base or the height? We know the height is 19, and we actually don't know the base, so let's just keep that as base. So now let's plug it in. We're going to plug these in here. We're going to have 133 equals the base times 19, which is the height. Now, how do we solve this? How do we undo multiplying by 19 to get b alone? We're going to divide by 19. And the base is going to equal 7 feet. Okay, so that was just a little bit easier version. Basically, we were doing these problems up here. We were solving for the area, and these ones down here, we're looking for actual lengths. Okay, we did stuff like that before in geometry, so. All right, we're going to do one more example. We're not going to do checkpoint 4 because I don't like that one that much. So, solve a multi-step problem. You are vacuuming your living room and would like to know how much area you must cover. The shape of the room is at the right. Find its area. Because you guys know how, if you're me, you always, find the area of your living room before you vacuum it, right? You guys always do your math before you vacuum. That's what I do. I always make sure I know exactly what I'm working with here. And I always forget how much it was, so I have to redo it again every time I vacuum. It's kind of a pain in the butt, but. Anyways, so we are vacuuming this kind of weird shape here. And if you remember back up earlier in the lesson, we were talking about breaking it down into parts that we thought would be easier to work with. So what I might do is I'm going to draw a line here to make this into two shapes that I know we can know. We don't really have a area formula for a shape like this. But what we can do, I'm going to draw a line here and see if you guys can see what shapes we have now. Now, what two shapes do we have now that I drew that line there? We have a square and a rectangle. So the total area, this is totally legal, you can split it up into two smaller parts and add them together, is going to be the rectangle plus the square. Rectangle plus the square. Okay? And then what I'm going to do is I'm going to write the area formula for both of these. Let's actually write that a little bit closer to where it's supposed to be. Area is going to equal, what's the area of a rectangle? Well, it was length times width. And what's the area of a square? It was a side length squared. Okay. So why don't we label what we know here? What is the length of the rectangle up there? So the rectangle's up here. So what's the length of that rectangle? It's going to be 9. What's the width of the rectangle? It is, ooh, this is actually kind of tricky. Let's talk about this. So the width of the rectangle, we know that this whole length right here is 9, and we also know that this part right here is 5. So if up until here is 5, what is the rest of it going to be? If the whole thing is 9, well, 9 minus 5 is going to equal what? Oh, it's going to be 4. That's kind of cool, actually. I kind of like that. Okay, and then the side length of the square is going to be what? It's going to be 5. Okay, so sometimes with these ones where you split them up, you kind of have to split up, like figure out if the whole thing is 9, then this is 5, then you got to like subtract 9 minus 5 to get whatever. This is going to be what's left over, which is 4. Okay, so area is going to equal length times width. We got 9 times 4 plus the side length square, which is 5 squared. And then 9 times 4 is what? 36. And what's 5 times 5, or 5 squared? 25. And then the area is going to equal 61 meters squared. All right. So still kind of tricky, but yeah, hopefully that makes sense that if the whole thing right here is 9, and this part of it, this up to here is 5, then the rest of it's going to be 4. Okay? All right. I think that's all we're going to do today. I don't think I'm going to do any more. Okay, thank you guys for watching. I hope you guys have a great day. And make sure you get your homework turned in the first 2 days to get feedback. Otherwise, you can turn it in up until the mini quiz for full credit, but I won't give you feedback unless you turn it in on time, okay? Unless you have a different, not accommodation, but you have a different arrangement with me to turn it in later, and you know who you are if that's the case, okay? All right, thanks for watching. Have a great day, and we'll talk soon.